thank you. I have to remember to shorten those short bios, otherwise they get boring. Thank you very much. So, this is the outline of my talk. I will first try to convince you there exists something called pervasive AI and why it does matter. And in the end, I will show you that that's a very good excuse to do some design of neural networks and to influence how you do design of neural networks specifically for distributed and embedded environments. Then I will go through how you learn in this specific distributed environment, talking about learning in space and time. And in the final part, I will sort of connect neural nets or dynamical system and why they need each other. And, well, it concludes with the usual self-promotion in the final part that you would expect from any presentation. So let's start from the first bit, okay? So let me stand in front of the camera otherwise. Perhaps unsurprisingly, pervasive AI comes from when you put together pervasive computing and artificial intelligence, which basically means that there are two dimensions of research in this field. So on the one hand, you have what happens when you start considering the fact that your learning model, your AI model, doesn't live in a vacuum, but rather is deployed somewhere. And that somewhere is a device with certain constraint, or it's multiple devices, it's distributed. Because the communication is constrained, or you have orchestration undergoing your application. So how do we make learning models informed of the computing and communication fabric they're executed on, and possibly optimized for that? There's the other direction, that is the how do we make computing and communication fabric specialized for executing machine learning AI models. Okay, so this is clearly a field in which you need to put together expertises. From one hand, pervasive computing expertise, on the other hand, AI people. Just to give you an idea of a very simple application we can relate with, the kind of prototypical application you can expect is something that takes in input a certain number of physical or virtual sensors, something that really measure things over time, and through some black box magical machine learning model or whatever, you come up with some refined predictions. This is not really working. Doesn't matter. At the bottom of the picture. This is basically there mainly to identify what are already some of the interesting points that these learning models need to have. First of all, they need to be able to deal with that type of data in input.